Welcome to Dave and Dharm Demystify, a FinTech Futures podcast, helping make sense of the world of FinTech and digital finance. Please sit back and listen as the two Ds take a subject and discuss it to make it clearer and easier to understand.
Demystify.
Welcome everybody to the Dave and Dharm Demystify show, and this week I have actually some fellow colleagues. From the newly formed company OpenCoreOS, we have the two founders, Ricky and Slavo. Welcome, guys.
Thank you.
Good to be here.
Good to meet you, Dave.
Would you mind just giving a brief intro to your background and then just tell us a bit about OpenCoreOS?
Yeah, sure. So I don't know what short means, but I'll do two sentences. Again, good to meet you. Good to be here. My name is Slavo. My background is software engineering. So I spent the last 15 plus years designing distributed systems in a variety of different industries. And then somehow ended up doing banking since about 2017 or so. And I put all of my engineering experience and sort of building systems at scale into practice. Really liked the sort of the challenging problems to solve in regulated industries such as banking. So since about 2017, just been focused on core banking and payments predominantly, but I'm sure we can discuss in more detail. Ricky, over to you.
I mean, Slavo's being very humble. He's like one of the best engineers in Europe, and he's our CTO, so we're in good hands. I'm Ricky Marcon. I've been sort of business building, product engineer for the last 15 years, started my career in consulting, left to do a startup myself maybe 10 years ago, and then did business building in McKinsey for the last 5 years with Slavo. That's where we met each other. In fact, funny stories, we built a digital bank 6 years ago now in the UK together. And that's where we started to learn about deeper core banking systems and experience firsthand the good, the bad, and the ugly of these different types of systems. And we actually thought back then that there should be a better solution in the market. And then fast forward to now, and we're actually building that solution. And then on OpenCore. So OpenCore started when we crossed paths with Karim, our other founder. And we got talking about sort of core banking systems and what the future should look like. And at that point in time, it was sort of the tail end of last year. You know, there was an inflection point happening with AI at that time. So the traditional path of building these types of systems would require sort of hundreds of engineers and teams and product people to build it. But we saw this new sort of alternative path of building with a lean, agile team that were sort of a set of well-seasoned product engineers using AI in a unique and novel approach to actually really build a new type of system, also from the ground up to solve for the new requirements and the type of AI era that we're in and find ourselves in. So everything we've done today has been designed for AI and for non-functional requirements that we focus relentlessly on, because some of the challenges we face, which we'll talk about, has been the scalability of existing incumbent platforms. So we are in this, I think, unique period of time where there is a new breed of core banking systems being created, being developed, that is right for this type of sort of agentic era that we find ourselves in. And that has certain consequences of how you design these types of systems, which we found out this year. But we've got we've been doing some very interesting work and development in this space that we think we have a very unique and novel way of approaching core banking systems.
And you mentioned kind of scalability. I mean, why do the banks need to scale more? I mean, what's the problem there? Is there really a scalability problem, or what's changing to cause the problem?
So on scalability, we've been in the industry for upwards of 10 years now, and some of the key challenges have not gone away in terms of the ability for some of the core banking systems to scale to what we just define as tier one workloads, or the biggest banks in the world, essentially. And these are banks with upwards of 50 to 100 million customers processing over 300 million daily transactions. And the existing sort of cloud native solutions didn't scale in the way that they were anticipated to scale. The cost was not solved. The operating cost of running these systems at scale in those environments didn't come to the expected fruition that everyone thought would happen 10 years ago when everyone said move to AWS or GCP or Azure. So what we're seeing now is there's still a big gap in solving this problem, meaning there is no real solution right now for the existing players in the market that can provide this level of this high throughput support for tier one workloads. So again, the OpenCore was founded on the premise we want to support the largest volumes in the world in a distributed fashion that is mission critical, meaning like the solution we're putting forward is indestructible. That's how we want to describe it. And for that, Slavo will describe what we're doing in that space to make it indestructible. But it comes with a whole set of new challenges and complexities that have not been solved today. And there's been fundamental challenges with just technology in general for the past 10 years on just database technologies and things that prevented these solutions from working at scale in a distributed fashion. And we're again at this sort of turning point or inflection point where the technologies sort of mature enough. AI is a big factor in the design decision-making process. So all these things together have helped us design a new system that can support these types of workloads in a cloud environment or sort of private cloud environment and move away from the traditional sort of mainframe approach. Because up until now, the reliability on cloud has been patchy at best. Running at scale in these sorts of environments comes with a lot of risk and resiliency concerns. I mean, we saw recently AWS go down. We've seen Azure recently have issues. So like these issues are still happening even in today's environments. So if you're a banking exec, you're looking at the instability in that space and saying, well, we can't trust putting 50 million customers onto this single region or even multi-region or one provider. So how do we think about solving this problem? And that's what we've done this year.
I heard a couple of interesting things there. So maybe flip to Slavo. Can you explain when Ricky talks about distributed and also talks about not having the problem of a single cloud provider? What is it you're doing different that other people haven't done to date?
Yeah, I mean, maybe just to add to the previous point, I think the other thing that's obviously changing is the move to real time, which it feels like has been happening for the past 3 decades. And everyone is talking about real time is only going to increase the number of transactions processed in these banks. But it definitely feels like we've been talking about it for a while. Obviously, the UK is a little bit different to the US. But indeed, with crypto and stablecoin, there's only volume of transactions that will need to be processed in real time is only going to increase. Now, a lot of the incumbent cores or the heritage cores obviously primarily work on batch with tight processing windows. So that's one thing. I think the other thing is the current next-gen cores, or what we currently call the next-gen. As Ricky said, we're not really proven at the scale of a tier one bank. So there's nothing really in production running at 100 million active accounts, 300 million transactions processed per day. And so those are some of the things that we've really thought about very carefully when we sort of set out to design the system. Now, when we say non-functional requirements are distributed by nature, what we mean is we want to be the first ones to be able to run across multiple clouds with zero downtime and zero data loss. So instead of traditionally what was happening in the industry, when we say cloud native, it typically means that it operates in one cloud. So a core banking system provider would basically build out their platform and they would be either running on AWS or GCP, but essentially that creates this sort of single point of failure. Now, obviously, it's been historically quite rare that the entire cloud provider would fail, especially globally. But as we saw over the past few months, there has been a GCP outage, there's been a massive AWS outage, and now there's been an Azure outage, I think, last week. It's pretty interesting. And so our platform is designed from the ground up to run across clouds, right? So essentially what we're trying to do is eliminate the next level of failure domain, which is the cloud provider failure. So in the case that there is a misconfiguration or DNS issue in GCP or AWS or Azure, our platform runs in what we call a stretched topology or stretched deployment, meaning there is no single source of truth in one or the other cloud. The source of truth is distributed across clouds. And so there is some magic, obviously, that happens behind the scenes to correctly configure it such that when an outage does happen or when you lose certain number of nodes in the database, you can still run the system reliably without any data loss. And that's really the most difficult thing is how do you tune those different levers and which you can pull to have the right performance, to have the right scale, and to have the right resilience at the same time and a manageable cost, right? So there are multiple levers you can pull. They result in different characteristics of the system. We're really trying to land in a position where we can say, hey, we can run 100 million accounts. We can run 300 plus million transactions per day at a very good performance footprint and a good cost. So that's really the challenge for us. But as I said, the system design has been informed by all of these aspects that we just discussed.
I mean, can I ask, because you'll have to forgive me, it's probably going to be a really stupid question, but are you then working with other vendors so you're providing the resilience layer to other vendors, or are you actually starting to build out a kind of core banking platform in its own right?
So all of our technologies are what I would call vendor agnostic, in the sense that if we think about the cloud, so we're not using the AWS version of the database. We're not using the AWS version of the event streaming platform. We're using an open source version of the event streaming platform. Therefore, we can run across clouds and we can even run on-prem. So as long as our customers can run Kubernetes, we can run our platform in any sort of configuration. So we're not locked into AWS for them to provide the managed service. We use the Kubernetes native version of that service or capability. And so, yes, we provide the platform can run on any cloud or on-premise environments. The most challenging thing is, I guess, the network behind it. How do we make it stretched, so to speak? How do we make it so that you have 2 or 3 different data centers actually talk to each other in a way that they don't need to know about each other, right? Whether it's AWS, GCP, Azure, that should be transparent, right?
You talked about agentic and this sort of new world of AI. I mean, talk to me about that, because how does that sort of play into what you're doing? Because again, I'm still trying to get my head around, and you'll have to forgive me, I'm just the user experience guy, but I'm trying to get my head around how you fit into core banking sort of pie, so to speak.
Yeah, maybe it's worth we go up a level on what OpenCore is in terms of how it's sort of thought about and positioned today, which is as a core banking platform, we focus, when we say core banking platform, it can be misconstrued in many different ways depending on who you are in the market. View of the world is we're essentially redefining the term core a little bit with OpenCore, meaning we are focused purely on sort of the ledgering capabilities of what a core we believe should do. And we're very opinionated of what the core shouldn't do. So we don't do things like, we don't have a customer master component, for example, in OpenCore, right? Most of our customer design partners already have these sort of solutions in place. Another one would be like a product and pricing engine. Again, a lot of these components in traditional monolithic cores have already been or are in the process of being externalized. So when we think of a core, we really think about the transactional engine or heart of a bank or any sort of ledgering capability. And for that, we provide basically a thinner version of a ledger that can do interest calculations, process transactions, and do reconciliation at scale, right? And that by itself is a lot to ask for from a resilient core. So that's our definition of really what a core is. And then when we talk about AI, this is all deterministic, right? What I just described. So when we think about AI, we're thinking about how do you interact and set up the sort of product configurations and operationalize this type of core, right? So you can create the concept of a virtual account in OpenCore, but that virtual account by default has no behavior. There's no interest calculations. It's a discrete container of value with balances. So what we're doing with AI is building, abstracting the way you interface with this core. To put maybe an analogy or comparison to existing cores, in other existing cores, you would have to go through maybe lots of different forms to create the configuration necessary required, or you might have to write code to configure the core to get some sort of product behavior going in the system, so that when you originate a new account in that core, it has some level of financial behavior that it will charge a fee at this point in the life cycle and it will do this every single day, for example. For us, we're using AI to simplify that process of creating that initial product configuration. So the interface with the system is natural language, meaning you would say, Dave, I want to create like a checking account. Maybe it's the US checking account. I want an overdraft facility. I want to have this type of interest rate on it. I want to have these types of balances to match what I have or my other existing products, or I want to innovate an entirely new product with new features. You basically specify the financial behavior that you want. We take away all the complexity of managing the sort of primitive building blocks that we have as OpenCore to create this behavior. And then we steer the end user, whether it's a product manager or the business, through the process of creating this basically product and operationalizing it on the system. And they don't need to engage engineering. They don't really need to engage anybody else to get this into a sort of a draft pre-live state where they can review and go live with that sort of product configuration. So it's really just abstracting away the complexity of these cores, because inherently we have Lego building blocks that we call primitives in the system, but we don't want, in this sort of agentic era, there's no need to actually fully understand what all the different properties that OpenCore requires to get that financial behavior. We're really changing the way you interface with the system. So it's really just via a business interface. And then engineers and systems integrators can also use it to rapidly configure the system in any way, shape, or form. But what we're seeing as we were developing the systems, as a team, we really heavily relied on the agent experience to really work on building out products and testing the system. And really it's at the main interaction pattern now is changing from form building and code-based implementations to really agentic approaches, meaning you just use natural language to ask what you want. And we're able to steer these systems and sort of multi-agent systems really well now, that we can get to the outcome in a deterministic way, relative and reliable way every single time.
I guess there's concern about the AI market being a bubble, because I've been reading a lot of businesses are not finding true value in AI, but it sounds like you are. I mean, just sort of allay my concerns that what you may be talking about is vapor. And maybe this is a good opportunity to bring in Dharmesh as well. So Dharmesh, I'm going to turn the table slightly and ask you about this, because you've just joined the board of the business and I know you would have done your diligence. So is Ricky telling me the truth about what this platform can do? It almost sounds too good to be true, to be honest.
I mean, I think the important thing here is that firstly, I feel like these guys have been reading my articles and putting it into the software almost, because I've talked quite extensively about kind of agentic banking. But more than that, it's not what other companies are doing, which is taking like generative AI and adding it to a specific function or a feature of their product. This is about actually being ground up native AI driven, so that you not only design the banking system, but you operate the banking system and you operate as a company driven by AI. I mean, I have to say, these were the first guys that I met that I thought this was an AI native company building an AI native product. So when I left Temenos, I was interviewed by the chairman there, and he said, "Why are you leaving?" And I said, "Well, I just can't see anything changing the market. And to be honest, I only stayed here because I thought I could change the world of banking, right?" And he said, "Well, what do you mean by that?" I said, "Well, look, your objective here is to go from a £1 billion software company to a £5 billion software company. My objective is, can I manage 5 billion accounts? That would change banking globally, right?" These guys are kind of driven by this world, which is very different to the old legacy banks, right? So that's the reason why I joined, was I could see what they were doing would have fundamentally not only changed software delivery, but will change banking for banks. And for me, that was very exciting, too exciting to say no to, really.
Oh, fantastic. I guess what I'm hearing from what you're saying, Ricky, as well, is that it sort of makes the way of building sort of products a lot more straightforward. Now, that plays into a kind of the future, I guess, where actually the customer of the products may not be people, it may be other agents. And like Dharmesh write for FinTech Futures, and one of the things I've written about is how, the future of banking is going to happen almost at the speed of light. So products will be born and killed off in fractions of a second based on what's going on from a kind of a macro environmental perspective. So it's interesting that what you've got is a platform which it sounds like would be able to kind of cope with doing things very quickly.
Exactly. I mean, at a very high level, the way the financial behavior is sort of applied to accounts is through data. So we work on the premise that data will be the currency for agentic workflows, and supplying data in different ways and shapes and forms allows us to change and model different behaviors in basically real time across all accounts on the platform, meaning you have this ability to in real time change the behavior if you so wanted to, right? So it enables a whole new way of thinking about product operationalization in the banking space. And the difference between us and some of the heritage cores and even some of the next gen, is that the way we've designed it has been to solve for this problem day one, meaning we saw the rise of agents and what they could and couldn't do and how to best to leverage them. And the best way that we think they should be leveraged is by using data as the sort of currency here, right? So we configure things via data, which is a unique way of providing the best of both worlds in terms of flexibility when it comes to configuration and simplicity around how easy is it to configure and adopt, say, such a platform like OpenCore. Because the last thing we want to do is provide a set of foundations that restrict and constrain banks from innovating in a product space. So how do you solve that without asking them to basically write code themselves? And that's a challenging design that we believe we've solved and have a solution for. But yeah, that's the way we're seeing the future here.
I mean, again, it's interesting because, I guess banks would have always thought of themselves as they moved integers from one spreadsheet to another, but do it in a very secure way. So it's about transactions. But I really take your point around data is, this is about a kind of data play. I mean, it reminds me of when I first met Dharmesh. I was working at a business called Yellow Pages, and that was in Reading. And I left Yellow Pages to join the business that Dharmesh was in because I couldn't get Yellow Pages to understand that they were a data business, not book business. It's interesting, like the legacy thinking that the finance industry has around that sort of transactional element, and I'm talking about the kind of traditional core providers, will really probably hold them back in a way that you've kind of freed yourself. So I can see what Dharmesh saw in you, and I can see that obviously doing some fluffing around building a product around his articles doesn't do any harm either. But it's a really interesting space that you're kind of moving into.
Yeah, I mean, it's a bit of a paradigm shift for banks to think about the workflow of how to operationalize products. So it's just shifting the way they typically originated, designed, configured, and deployed these products in the market. So if you look at everyone who's using, every bank or every core banking technology vendor in the market is using AI now and applying it in different ways. But from those existing platforms, it's really hard to redesign the workflows, right? Whereas, again, that's why when we say AI native, which is a kind of a buzzword that gets overly used. The way we think about it, that is designing a platform with AI in an AI first way, meaning every decision we've taken with how we've done the architecture is designed such that it takes advantage of these AI systems, meaning agents in practice. Otherwise, you can't build these types of systems in general.
No, and then, Slavo, I can see how that then connects to the need for kind of ultimate resilience as well. So I guess the question is did you start with the data sort of idea, or did you start with the resilience idea and kind of work? Which way round was it?
I mean, it has to be both, really. I think we have a good combination here where, Ricky's the visionary AI, what the future holds. I'm perhaps in the best way possible, maybe the more traditional sort of like, how do we actually make this happen? And also thinking through my experiences building on many different core banking systems and operationalizing banks and payments, working for some of the biggest banks as well. I mean, seeing the process, seeing how things work and where they sort of shoot themselves in the foot. I think a really interesting challenge for me, thinking through what that architecture actually looks like and how do we enable this type of interface and this type of experience. Obviously, it ends with the user typing in a prompt or typing in or trying to compose a product. But what happens behind the scenes, it's almost as magical. It's just you don't get to see it. Now, as Ricky mentioned, it's sort of that in between flexibility and simplicity. So, how do we create these foundational financial primitives that we think in decades, we don't think in the next sort of 2 to 3 years. So what is that? I like to refer to as the standard library. What is the set of standard building blocks that we have in the system that the agents can work with really well, really quickly, really sort of in maximum flexibility, but that doesn't put the burden on the end user or the API integrator where they have to sort of understand every single sort of detail of that data model. How do we do that? How do we document it? How do we prepare it for the agentic future where, MCP servers and AIs and agents are going to our documentation, our code base, our data API definitions, truly understand how to compose those things, right? Because without that, it's practically impossible. So it was really about how do we think about this from first principles, all the way from how we design our code bases, how we design our repositories, our documentation, our data models. Because when that foundation is set, it makes everything so much easier and so much quicker. Like we can develop new functionality through composition extremely quickly because we have this standard library of financial primitives.
Slavo, I mean, this is quite fascinating. For a company that has, let's say, a Mac architecture, their microservices, API first, composable, headless, right? That would be probably the modern core today is a Mac architecture, right? Can they do what you guys are doing just by adding AI to a modern architecture? And if they can't, why can't they do that? I mean, can we demystify that bit?
I think to a certain extent, I think it just depends. I mean, are you referring to specifically, financial?
Like if I look at somebody like, well, all of them, right? Monzo, Starling, all of them have said, we've gone to a microservices architecture, we're a modern core, da, da, da. Could they now just add AI to achieve the same kind of flexibility, whether it's moving between clouds or product configuration? Can we get to this by adding the AI?
I'll cover two things, and then I'm sure the third one, Ricky, will cover the end user aspect. I will cover it from the performance and resilience piece on the one hand, on the other hand, the flexibility piece. It's very difficult to go back and say, we've got this live system, which has been built, say, on Postgres sort of database. It's very hard to go back and say, we've got all these live customers. We have, a few million accounts running. Let's just rip it out and replace it with a different database altogether that is better suited for this distributed sort of multi-cloud deployment model. It's incredibly difficult. And it's not just the database, it's also the data streaming platform. It's basically Kafka. Like, how do you make Kafka truly active? How do you make sure that you have a cluster of 6 Kafka nodes? If 3 of them go down, you're still operational and you have 0 data loss and 0 downtime. That is really the difficult bit. And now you would have to go back and really rip and replace your entire tech stack to support that while supporting millions of customers. So that's not easy, not for a bank, not for a core banking provider. And remember that the next gen providers are today pretty much 10 years old, most of them, right? So the decisions they would have made are very much sort of 10 years ago with the tech that was available at the time. So I think that's on the, how do you make it resilient? Now, obviously you can always make things more resilient. It's just not as easy and it requires an enormous investment and effort across the board. That's one side on the resilience. I think on the flexibility, it's even worse. It's even more difficult because, again, we had the freedom and luxury, I dare say, to really think through this from first principles, unconstrained by having existing customers, having to support certain use cases. We could really go to town with how do we think about what good looks like in the next generation of, as I said, we think more in decades, less so in the next 2-3 years. What does that feature look like? We've had the luxury of time and experience and AI, frankly, to help us in a lot of the design. So the majority of time we spent designing the platform was really getting all the best models in the world with our experience and our understanding of what good looks like, pressure testing the designs with all our AI friends, as we refer to them, and get to the point where we're happy. We're in a position where this is solid. This will withstand the test of time. Now, obviously, nothing is bulletproof, but I'm confident we're in a very good position where we can, the flexibility that we talk about is actually really difficult to achieve unless you start from first principles. Because if you think about traditional banking and how you think about the different domains around accounts, products, balances, they're very rigid, so to speak, right? So a deposit account is a deposit account. It has interest, it has some limits, it has an overdraft facility, and that's pretty much it. In many of the platforms, you can't even do anything apart from fiat currency backed deposits, right? And so what we're really thinking about is how do you decompose these foundational primitives, like interest is one such behavior or capability, limits is another one, posting rules is another one, funding strategies would be another one. So how do you take money from the account? How do you repay money back to the account? If you can make these foundational primitives or standard library composable, flexible, and extensible, that's the winning recipe for us, right? Now that is pretty much impossible to go back and redesign how Monzo sort of thinks about their architecture, API design.
It's pretty crazy to think that a 10-year-old architecture is already legacy. But Ricky, did you want to add anything to that?
Yeah, I mean, on the AI side, I think the question was, can't they just sprinkle or implement AI and call it a day? And the challenge with that is, if you look at some of again, it comes back to how they were designed from day one, which was without AI in mind, which has severe consequences today. I think one of the earlier blog posts from Monzo was it had like 2,000 plus microservices. I'm not sure where they are today, but I can't imagine giving an agent 2,000 tool calls to make, just meaning that you have to give it 2,000 ways to do something. It will collapse under that pressure, and you'd have to rely on very complicated multi-agent systems, which are still a bit troublesome to sort of get working properly at scale. So again, some of that initial design to go full microservices can actually hurt a lot of old companies in the last 10 or so years. Just the way APIs were designed 10 years ago could make leveraging agents a lot more difficult for companies today. Whereas we know what makes agents work effectively and what they need to work effectively, and we've designed for that. So that's, I think, the biggest shift. And then rethinking these current business processes in how you configure these systems. So again, it changes how we think about configuration from day one, and to sort of retrofit AI into the older methods of configuration approaches, we don't think will actually work at scale in practice. So what we've been experiencing and testing has been a new method that is reliable in what it does, such that there's no issue with hallucinations that we may have seen 2 years ago when Gen AI was starting to get a real big foothold in the market and the hype was increasing. But we don't have those issues anymore. So we're able, with this type of architecture, to really steer our agents into the right path, and we're getting really good results with it. And to us, it's as reliable as being deterministic to a large degree. So I think that's the key difference is we've designed from day one with these characteristics in mind, and it's changed how we think about this interaction pattern with the system. So we don't have these long old business processes that we used to follow when we were implementing these core banking systems. And we've just completely flipped it on its head and said, now we can actually do it a different way. How about we design for this new way of thinking? And I think if you're an existing core banking vendor or technology provider, even any fintechs in the space in the last 10, it's really difficult to rethink your whole platform from the ground up. And it's probably not feasible for most companies that have to basically build a direct competitor to themselves with an agentic approach to get the best value out of it.
I got to say that I had a conversation the other day with somebody about my previous startup, which was Ask Homie. It was a prop tech platform. And the reason it was called Ask Homie was the vision was very much you can ask this thing anything about your house and it would respond, like how much carpet do I need for the entire downstairs, or what would be the average cost of new windows, or et cetera, et cetera. You could ask it anything. And we started that platform in 2019. And I sold off the technology in 2022 because we just weren't getting the kind of experience that we wanted. And there was an offer on the table, et cetera. We took it. I was asked the question, given now with the progress of Gen AI, wouldn't that be much better just to add to your existing platform? And previously, we tried to automate the conversational interface with Alexa and Siri and Google, and that's a totally different experience. But the answer was very clear for me, which was, no, we fundamentally have to scrap the databases because there's a load of data we don't need to ingest. This stuff can scrape it off the web far more easily. There's a load of stuff that we built in just that for the older kind of approach to AI. It needed processing capability, et cetera. There were so many things that had come up in the last couple of years that actually it would need a rewrite to do it with the modern tech. And I guess that's what you're saying about banking as well.
Yeah, I mean, very simply, like there's a lot of older APIs that were designed 10, 20 years ago, 30 years ago that are very obscure. So as a human reading it, it's very obscure. And then you normally have to talk to the vendors to actually understand what it does. Now, if you give that to an agent, they have the same problem. They're confused by the language used 10, 20 years ago. So what has to happen is you have to basically redefine those APIs for basically human/agent to understand. So you get the most bang out of your buck so the agent doesn't make mistakes and think that this word actually means something else because it was misused. So when we do, when Slavo was mentioning sort of using AI and ensuring that all of our documentation is AI friendly, we expect agents to be reading this data, sort of API definitions, and ingesting it. And it's written so well such that there is no ambiguity in how we do a withdrawal, how do we do a deposit, or how we create accounts. So then it makes it very simple for agents to follow that interface. So what happens is you find out that, and in some scenarios, there are banks that don't even have documentation on some of their internal platforms, or there might be missing documentation or lack of documentation. So a lot of the companies will be trying to go backwards to fix foundations before they can actually get good value out of agentic systems. But we sort of, fortunately, our position, we can bypass all of that because we started with those correct foundations, as Slavo was mentioning earlier.
And we get help from AI to design for itself. So we can say, what would be a good design for this, where it would be actually better understood by an agent, right? So almost like meta prompting. And that's what I mentioned around pressure testing our designs. Often we would say we would run it across like 3 or 4 different LLM providers to get to the solution that was both human friendly and more importantly, perhaps agent friendly.
Amazing. Well, listen, we're not the Lex Friedman podcast here, so we're going to have to wrap up because we're tight on time. So I'd like to say thank you for joining us. I'm sure Dharmesh might have one last question he wants to sneak in.
No, I'm honored to be asked to join the team. And quite frankly, I'm very excited by the stuff that they're doing. So you'll hear more from this space, I think. And hopefully, Dave, we have demystified what agentic banking is all about.
Fantastic. Fantastic. And we've also demystified the fact that your mum had to pay these gentlemen for your new job. So anyway, thank you so much for joining us, Ricky and Slavo. Really interesting. And genuinely for me, I've had a couple of penny drop moments, which I think is always good. So thank you so much for coming on. Fascinating.
Thanks for having us.
Thanks for inviting us. Thank you.
Thank you for tuning in to Dave and Dharm Demystify. We hope you enjoyed the show. Don't forget to like and subscribe and tune in next time as we take another topic and demystify it.